Recording in progress.
Hi students, in this lecture I am going to discuss problems. Let us see first one. A circular plate of uniform thickness has diameter of 56 centimeter. A circular portion of diameter 42 centimeter is removed from one edge of the plate as shown. Find the position of center of mass of the remaining portion. This is the question asked in 1980. So given circular plate, uniform thickness, diameter 56 and 42. So for remaining portion, see how to solve these kind of questions. Let's see. First of all, write down the given data. Are equal to half of 56 means 28 centimeter. Let us take other one smaller. It is given 42. That means it is now 21 centimeter. The radii. Now see what we can do. From circular plate, remove one smaller one from the edge. So I want to generalize this one. Let us see, instead of removing from the edge, let us take, we are moving not from the edge, somewhere here. Let us take, we are removing somewhere here. Suppose separation between their centers, take it as D. Separation between the center of the bigger one to center of a smaller one, take it as D. Means we are now generalizing the problem instead of removing from the edge. Okay. Then see what we can do. Let us consider the line joining the centers as x-axis. So take this as now x-axis. Okay. Now here what I am doing is, once we are removing some part, for remaining part we have to focus location of center of mass. For remaining part, center of mass will be, so we can guess it will be somewhere to the left of the center of bigger one, right? For remaining one, center of mass will be to the left of the center of the bigger one. Let us take that distance as x, so which we have to calculate. So now what I am saying is, let us take the complete one as combination of removed one and remaining one. I am repeating. Let us take the complete disk as a combination of removed one and remaining one. Okay. Let us take mass of remaining one is m1. Mass of removed one is m2. Between their centers means center of the bigger one to center of the smaller one, that is D. So here what I am saying is, if you take combination of these two, remaining one and removed one, if you combine these two, then center of mass must be the center of the bigger one. Center of the bigger one. Let us take that as origin. That means xcm. It is 0. So I am taking the center of the bigger one as origin. Therefore, if we combine removed one and remaining one, then center of mass must be at origin. Okay. Now see carefully. xcm equal to m1 It's a position coordinate. I have taken x as a distance, okay? X distance means coordinate will be minus x, okay? M1 x1 plus m2 x2 value. It is equal to d, right? Separation d upon m1 plus m2. But we have taken this point as origin. That means it is equal to 0. See, from this what we are going to get? m1x is equal to m2d. So let us now use this one for all problems. Means whenever we are removing a path, okay, we can use now this result. Let us see how to use now this one in the given problem. It is a disk. Disk means mass equal to volume into density, right? Volume pi r square, that is area, into thickness, that is volume, into density. Now you can see for removed one having same thickness and same density. That means mass proportional to square of the radius. Mass proportional to square of the radius. Okay. So in this problem, 28 and this is 21. That means what I can do is m1 will be mass proportional to r square. So I'm writing here in the place of m1 28 square minus 21 square because proportional to r square into x is equal to m2 proportional to r square 21 square. Separation between them, it is given that removing from the edge. Removing from the edge means d becomes 28 minus 21, that is 7. Okay. D becomes 28 minus 21 because removing from the edge. Now remaining just a calculation part. A square minus b square, a plus b into a minus b. 28 plus 21, 49. A minus b, 28 minus 21, 7 into x is equal to 21 square, 21 into 21, remaining 7. 7 gets cancelled. 7 cancels. Next, in 49, 7 times, in 21, 3 times. And again, this 7 in 21, 3 times, remaining x equal to 9 centimeter. That means center of mass shifts by 9 centimeter. Okay. So whenever any question given, we can use now this result. That is m1 mass of remaining one into this is now shift of center of mass. Okay. Initially center of mass was at this point, center of the bigger one. Now this is the center of mass for remaining one. X stands for shift of center of mass. So mass of remaining into shift of center of mass, that is equal to mass of removed into its distance from center of the bigger one. Okay. So without by hearting anything, just take this as origin and using this result. Okay. Let us see next one. Same kind of questions. If you want, you can try once. If a triangular sheet is removed from one edge of a uniform rectangular sheet with its vertex at the center of the sheet and its base touching one side, given smaller one, right? Smaller length. Then the shift in the center of mass of the system. Okay. Right. See, Again, doing the same thing. It is a rectangular sheet. Sheet is rectangular. Given that removing a triangular plate, its vertex is now at center of the rectangle, and it's a side touching now. Right, this is a straight line. Right. Then see what happens. For remaining one, center of mass. Initially, center of mass was center of the rectangle. Now, center of mass will be somewhere here. Suppose shift equal to x. So, I'm writing here m1 x is equal to m2 into d. m1 means mass of remaining one. Here also same logic. Mass proportional to area, because for both the same thickness and same density. So coming to M1, what I'm doing here, mass of remaining. Area is length into breadth. From that subtract area of the triangle. Half base height. Height is nothing but L by 2. Okay. This is area of the remaining one into X. So why taking area means? Because mass proportional to area. M2, mass of triangle. Half base, half base height is L by 2, right? Now you should be very careful while taking D. Distance of center of mass of removed one from center of the bigger one, okay? Means from center of the rectangular plate. You can see this height equal to L by 2 and this length equal to 2/3 part. It is a 2/3 part of L by 2. I hope you are getting this point. Why we have taken this one? In a triangle, if h is altitude, centroid will be at a distance 2 by 3 times from the vertex. Okay, from the vertex, distance of centroid. That is what I have taken here, 2 by 3 into L by 2. Okay, total is L by 2. Remaining is just a calculation part. See carefully. So we can cancel throughout B. We can cancel L also here, L and 1L. Remaining is now 1 minus 1 by 4. Means x by 4. Wait. 1 minus 1 by 4, 3 by 4. 3 by 4 is equal to, here 2 gets cancelled. Remaining is L by 2 to 4 and 3 also there. 4 and 4 gets cancelled. That implies a shift equal to L by 9. Okay. Using the same result. Right. M1 x1 equal to M2 x2. Let us see next one. If a spherical portion of radius r by 2 is removed from a uniform sphere of radius r from one edge, then find the shift in center of mass. So again, same kind of question, but this time it is a sphere. Okay. And the last question we have solved, removing circular disc, right? This is now sphere. Radius is r by 2 from one edge. See what we can do. Diagram again same. From a bigger sphere, removing one smaller. Now this will be again from edge touching the center, because given this is r by 2. Okay. In case of a sphere, mass equal to volume is 4 by 3 pi r cube into density. For removed one, density again same. So mass proportional to r cube. Okay. That means for bigger one, if mass is capital M for bigger one, for smaller one, mass will be m by 8. Then for remaining one, mass will be 7m by 8. Okay. Now see condition. m1x is equal to m2 into d. m1 mass of remaining one 7m by 8 mass of remaining one. X we have to calculate m2 mass of removed one, that is m by 8 distance removed from the edge, then d becomes r minus r by 2. It is r by 2. m by 8 gets cancelled. X equal to r by 14. Okay. Like this, whenever we are removing some part of the body, then for remaining part, where is the center of mass or what is shifting center of mass, we can calculate like this. Okay. See next problem. This is a previous IT problem. See carefully. A small sphere of radius r is held against the inner surface of a larger sphere of radius 4r. The masses of larger and smaller spheres are 4m and m respectively. The arrangement is placed on a horizontal table. There is no friction between any surfaces of contact. The smaller sphere is now released. Find the coordinates of the center of the larger sphere, means coordinates of center of mass of larger sphere when smaller sphere reaches, wait, find the coordinates of center of the larger sphere when smaller sphere reaches the other extreme position. Okay. So this is the question asked in 1996 for 3 marks. Let us see how we are going to solve this one. First, make the diagram. This is now given as x-axis. There is one smaller one here. Its mass is m, radius is r, and for bigger one, radius is 6r, and mass is 4m. Okay. And given coordinates of the bigger one, L, 0. Now question is, when smaller one reaches the opposite end, this end, we have to find coordinates for center of the larger one. Okay. See what we can do. So this is actually momentum conservation, right? Here, if you focus horizontally on the system, no force is acting. I am repeating, in horizontal direction on the system, no force is acting. Therefore, initially, see, given that released means VCM equal to 0. Condition 1, released. Okay. That means in horizontal direction, no force means acceleration of center of mass along x-axis is 0. That means velocity of a center of mass along x-axis is 0, remains a constant. No acceleration along x-axis. Means x component of VCM must be always the same, 0. That means there is no shift of center of mass along x-axis. That means delta xm must be equal to 0. Delta xm must be equal to 0. Then see what we can write. m1 delta x1 plus m2 delta x2 equal to 0. Relation is that this is m1 delta x1 plus m2 delta x2 by total mass, right? When you are saying total mass, this is not 0. So this is 0 means numerator value must be 0. That's why this is 0. Now to understand, you assume that when smaller one is moving, you assume that bigger one is not moving. Then see what happens. Center of the smaller one, when it comes to the other end, from this point to this point, distance equal to 10r, right? See, total value 6r. From here to up to here, I can say this is A, this is B, and this is C. A to B, distance 5r, A to C also 5r, totally 10r. Okay. But when it is moving like this, bigger one moves by some distance, take it as x. Therefore, for smaller one, displacement will be, in ground from displacement will be 10r, 10r, or do one thing. Let us take a sign convention here, taking right as positive, taking right as positive. Then what I can say is, displacement in ground frame is equal to x minus 10r. See carefully. A to B 5r, A to C 5r, total is 10r. But at the same time, bigger one is moving, x right side. So net value, x minus 10r, left as negative, right as positive, plus m2 value, given 4m into x equal to 0. Remain just a calculation part, m gets cancelled, 4x and x 5x equal to 10r. That means x equal to 10r by 5. It is a 2r. That means center of the bigger one moves by a distance of 2r right side because we got x value positive. That means now coordinates of the bigger one L plus 2r comma 0. This is the final answer. Okay. Let us see next one. The center of mass of a non-uniform rod of length L, whose mass per unit length lambda equal to kx square by L, where k is a constant and x is the distance from one end is. So we have to find center of mass location, right? Given lambda kx square by L. Given kx square by L. Write in first what is given. Lambda equal to k x square by L. Suppose this is a non-uniform rod and taking this end as x equal to 0. Right. Now see how to find it. When you take this as x-axis, xcm is equal to Since the distribution of mass continuous, we have to consider integration of x dm by integration of dm. Okay. And here you are given lambda. Lambda is mass per unit length. When lambda is given, dm equal to lambda into dx, right? Now use that here. So we have taken at some distance x, element of length dx. Okay. Integration of x into in the place of dm, lambda dx, lambda kx square by l, lambda into dx upon dm kx square by l into dx. Okay. Like this, we have take all point masses from 0 to n. So limits are 0 to n. K by L gets cancelled. X into x square, x cube dx, x power 4 by 4, x square dx, x cube by 3. Now take limits. It is now how much? 3L by 4. Okay. So since we are given lambda, mass per unit length, so we have taken a distance x, element of length dx. The position coordinate x, it's a mass, lambda into dx. Remain just a calculation part. Let's see the last question. A shell of mass m in flight explodes into 5 equal fragments. So in flight means, here meaning of flight is, it is in air, okay? In flight explodes into 5 equal fragments. 2 of them reach the ground earlier than the other fragments. The acceleration of the center of mass of the shell system just after 2 fragments reach the ground is, asking the acceleration of center of mass of the system. Acceleration of center of mass of the system. Just a focus expression for that. Acceleration of center of mass of the system is equal to m1 a1 bar plus m2 a2 bar plus and so on, m1 plus m2 and so on. Okay. Right. Now see carefully. Out of 5 fragments, 2 reached ground. 2 reached ground. Remaining 3 are in air. Okay. These are in air. Equal. Equal means masses same. Now see what I am doing here. Whenever a body is in air, if we neglect air resistance, the only force is gravitational force. So for each particle, irrespective of their masses, acceleration will be g downwards, g downwards, g downwards, g downwards. So for 3, so I'm writing here m by 5 mass into g, like this for 3 particles into 3, plus for remaining 2. Remaining 2, they are on ground. On ground means their weight balanced by normal reaction. They have no acceleration. So 0. Okay. Upon total mass. Total mass is m. Okay. So we have taken m by 5 into g. Again m by 5 into g. And again m by 5 into g. So 3m by 5 into g for these 3. For remaining 2, no acceleration. They are on ground. Net force 0. That's why no acceleration. Remains simple. Mass gets cancelled. This is now 3g by 5. Just a matter of single equation. That is simple one. Okay.